Hello everyone, welcome to Practically We Bring Learning Alive. So you all are aware that we have started this term 2 one-shot series, right? So we will be discussing the entire chapter in one session and also with few of its examples and questions. So today in the term 2 one-shot mathematics subject, we will be seeing the chapter of circles, okay? So I hope I'm audible enough and the screen is clearly visible. So do comment if my voice is audible and the screen is visible. Okay, hi, a very good evening. Okay, so I'm audible enough, correct? So let me start. So before we begin the session, let us see the schedule of class 10. Okay. So this is the one-shot class 10 schedule. The time slot is from 4 p.m. to 6 p.m. and we will be covering math and science. So we have begun it from 1st February and it runs till 16th February. Next we have a sample papers of math and science and the time slot remains same, that is 4 to 6 p.m. And this is coding for class 10. For class 10 coding, the time slot is from 8 to 9:30 p.m. Okay, and then these other dates for coding class 10. So now we are done with schedule. Let's see what topics we are going to cover today and also about theorems, proofs and also word problems, correct? So we will see the introduction. Right. So we will see the introduction to the topic. We'll also see tangent to a circle and also we'll do a small activity based on it. We will see theorems and proofs and also some word problems. All right. So let's start. So let us consider a circle and a line PQ and check different conditions for it. So before, actually going into the topic, let us do this small activity, okay? Consider a circle and a line PQ. So here we have three circles, correct? So let us take a line PQ and see different conditions where I can place this line PQ, okay? So first, let me draw PQ like this. So this is a line PQ. So in this condition, you see that this line is not intersecting the circle, right? This line is separate from the circle. There are no intersection points between the line and circle. Figure 2, let me just draw PQ like this. Okay, this will take Q, this will take P. So can you tell me in how many points is the line intersecting the circle in the figure 2? It is intersecting at 2 points, right? So the line is intersecting the circle at 2 points, that is at point P and at point Q. So this is just, this is line PQ. Let us just say AB, okay? So the line PQ is very good at 2 points. Next, in the figure 3. Okay, so let me just draw it clearly. So again, this is also PQ line and in this it is intersecting at only one point A. Okay, figure 2 is secant. Very good. Yes, of course, figure 2 is secant. And can you tell me what AB is called? What line segment AB is called? Okay. Yes, line segment AB is known as chord. Very good, Lakshmana Prabhu. Correct. So we have seen these three cases, but what these three cases represent? So figure 1, PQ and circle has no intersection points. Second, there are 2 intersecting points, and in the third, there is only 1 intersecting point. Correct? So In this, it is known as a non-intersecting line with respect to the circle. Of course, we didn't see that PQ line is intersecting with the circle, correct? Next, there are two common points A and B that the line PQ and the circle have. In this case, we call this PQ as the secant of the circle. Okay. Next, there is only one point A which is common to the line PQ and the circle, and this line is known as tangent to the circle, right? Very simple. So we have seen three conditions. We have seen what is the tangent, what is the secant, and what is the chord as well, correct? So just let me draw a tangent here so that be clear. If this is a circle and if I draw like this, if this is the meeting point A, so we can say that line L is the tangent to the circle and they are meeting at the point, or they are intersecting at the point A. Okay. So next, tangent to a circle. So we have just seen that there is a condition where a line and circle intersects at only one point. It is called as tangent of the circle. Now let us dig deeper into the topic and understand what is tangent to a circle. We know that a tangent to a circle is the line that intersects the circle at only one point, right? Of course. So let us just perform an activity to understand. So here, let me take this point P. Okay. So let's draw like this, and I am just drawing all the lines which passes through point P. This is another line, L, M. This is another line, M. So how many ever lines you draw at point P, which passes through point P, we get only one tangent at point P. Okay, so just try this activity, take a circle, okay? Draw how many lines ever you want which is passing through point P. You see that every other line has some other intersection point with the circle. There will be only one line here, the line L, which is a tangent to a circle. So, what can we conclude here? We conclude that the line intersects the circle at more than one point in various positions. Exactly, right? So, we have taken these two. Let me just take other also. So, let me just draw like this. This is line E. So, you see that in the three conditions, that is line M, N and A, the line is intersecting the circle at two different positions, correct? Next, there is only one instance where line intersects the circle at only one point P. Alright, so here we have seen that there is only one instance, that is line L, which intersects the circle at only one point P. Next, this is known as tangent to the circle at point P. And the conclusion, that is the important note we get, is there is only one tangent at a point of the circle. So now what does this point mean? Let us draw a circle. Now if I take this point A, at point A on the circle, I can draw only one tangent. Okay, only one tangent. Now suppose let me take this point. At this point C, if I draw, I can only draw one tangent. So at any given one point of the circle, I can draw only one tangent. Okay. Hope you have understood everything about the activity and also the observations from it. Now that we have done, I am just asking you a question. Okay. So if I take a chord, okay. So I have drawn a chord AB to the circle. I want to draw tangents at point A and at point B. So how many tangents can I draw in all together at both points? Come on, answer it in the comments. Okay. So, okay, let me just draw. Instead of telling, let me just draw. Okay. So, there is a circle. Okay. I have drawn a chord AB here. So, I want to draw tangents at point A and point B. So at point A, how many tangents I can draw? I can draw only one tangent at point A, correct? And okay, Lakshmi Prabhu, that's it. I have drawn. So now, very good. Now at point B, how many tangents I can draw? Exactly, right? Yes, SRH2, 2 ma'am total. Yes, total 2 tangents and at A1 tangent and B1 tangent. Very good. Very good, Lakshmi Prabhu. Good. Both of you good. Next. The tangents to a circle is the special case of the secant when the two endpoints of its corresponding chord coincide. Of course, right? So when I draw a circle and if I draw this, it's a secant and it's a chord, correct? So it has two intersecting points. But what is the tangent? It is a special case of the secant where these 2 points coincide into one. So now this will be my tangent, correct? Very simple, no confusion. When these 2 points coincide into one, at that point the tangent is drawn. Okay? Is it clear? Now, the common point of the tangent and the circle is known as point of contact. Now, there is a line L, there is a circle with center O. Now, this X, there is the point X, correct? Where the line and the circle intersect. This point is known as point of contact between circle and line. Very good. Tangent has only one point of contact, and also we have seen a note in the previous slide that at any point of circle, at one point we can only draw one tangent, correct? So yes, tangent has only one point of contact. Here it is X. Very good. And now there is a question again. So, how many points does the diameter intersect at circle? At how many points does the diameter intersect the circle? If I extend the diameter. Come on, type the answer in the comments. Very good. At 2 points. So, yes, diameter intersects. If I extend the diameter, it cuts the circle at 2 points. Very good. Good, good. Correct. Next. So now we are done with the basic concepts of the circle. Let us understand theorem 1. The tangent at any point of the circle is perpendicular to the radius through the point of contact. So first, let us draw a circle. Okay. And there is a tangent. So let me draw a tangent. And there is also a point of contact, correct? Let me name this point as P. Okay. Now, what do we have to show? The tangent at any point of the circle is perpendicular to the radius. So there is also a radius. Let me draw radius. So OP is my radius, correct? Next. So we have to show that this is perpendicular. So how do we do? Okay. So let me just take other color. Now what I will do is, let me take any point X on the tangent. Okay. Take any point X on the tangent. So now tell me, can this point be on the circle? Is there a chance that this point X which I took, can it be on the circle? Hi Shabana. It cannot be on the circle. Why? Because we know that tangent meets circle at only one point, correct? And there's only one point of contact. So this X has to be outside the circle, correct? Very good. No, answer is no. Good. Now what I am doing is join OX. Okay, what is the next step? Join OX. Okay, this is one condition. Now if I measure what I'll get, OX is greater than OP. Correct? How? You might be asking, ma'am, how do we get? So just take measure. If you measure, you will be getting that OX is greater than OP. But this is one case. Now we have to check many other cases to understand why only OP is perpendicular to the tangent, correct? So what we'll do, let me take another one also. So here let me just draw OY. So even with this case also, we get OY is greater than OP. So when you perform this, you will be observing that there is only OP which is shorter than every other line segment, okay? So, how many ever points you take, like this, you see that OP is the shortest distance, okay? And what do you call the shortest distance? It is nothing but perpendicular, correct? Okay, let me just explain you this. Suppose there are two lines, okay? Now, I say that this is the perpendicular and this is the shortest. Why? Because if you take any like this, these are longer and these are also not perpendicular, correct? So, the shortest distance between the 2 points is nothing but perpendicular, okay? And what do we know about perpendicular? It is 90 degrees, right? So, that is what we conclude, that OP will be the shortest distance. Therefore, it is known as the perpendicular distance between the radii. I mean, it is perpendicular distance between the point O and the tangent. And therefore, this OP radius is perpendicular to the tangent. Okay? Did you all understand? So, let us just read the theorem again, because we will be using this statement in the problems. Okay? So, we will be using this statement a lot in the problems. So, the tangent at any point of the circle is perpendicular to the radius through the point of contact. Okay. Let me give you another example. Suppose if I draw a circle like this, if I draw a tangent, let me take this tangent as L. Okay. The circle center is O. Now, if I draw this OP, can I say that OP angle OP, let me take this as A and B, is 90 degrees? Can I tell that angle OPA is 90 degrees? Answer in the comments. Of course, I can tell it is correct. Why? Because we proved that this radius is perpendicular to the tangent at point of contact. So, this is 90 degrees. Therefore, I can absolutely tell that angle OPA is equals to 90 degrees. Yes, very good. Correct. Right. Next. So, we have to see what have we learned from the theorem, correct? So, by the theorem above, we can also conclude that at any point on the circle, there can be one and only one tangent. Yes, we have been proving this from the first slide itself of today's session, correct? Next, the line containing the radius through the point of contact is also sometimes called the normal to the circle at the point. So, when you say radius, at the point of contact, you can actually write it as 90 degrees, correct? And sometimes in few questions, you will be seeing that OP is the normal. What is meant by normal? It is again nothing but it's the line containing the radius through the point of contact to the center of the circle, okay? So, here A, B, O, K. So, here I can tell that OK is a normal. So, whenever it says normal in the question, you can just take it and put as 90 degrees. Okay. Hi, Aman Vahora. I hope you're doing well. Okay. So, now everyone, did you all understand the theorem and also the proof for it? because this time you may, it's subjective, correct? So you might be asked in the exam to prove a theorem, or it can be given as the question as well. So that is why I am asking you again and again, if you have understood the theorem, just yes, you have understood, okay, good, right. Next. Alright, so we have done the theorem. Let us solve some questions on it. We'll study whether we have understood, we got the knowledge about it. A tangent PQ at point P of a circle of radius 5 centimeters. Okay, so there is a tangent PQ at point P of a circle of radius 5 centimeters meets the line through the center O at a point Q so that OQ is equal to 12 centimeters. What is the length of PQ? Okay, in the outer circle, they give a point. We can draw two tangents. What is outer circle? Okay, so if there is outer circle, there should also be inner circle, correct? Yes. Now tell me, what is your doubt? In the outer circle, they give a point. Oh, okay, I understood your query. Correct. Very good. Yes, Lakshmana Prabhu, I have understood, and that will be our next theorem, okay? We will study that as well. Alright, I'm erasing this. Alright, so let us do this. Tangent PQ, first let us draw a circle with center O. Okay, you can also try it, because you have to just give me the length of PQ. No need to do any construction, right? Just tell me the length of PQ in the comments, okay? Right, circle O and Q, yeah, align through the center O at a point Q so that OQ is 12 centimeters. Okay, this is Q. Okay. Right, tangent PQ at a point P, radius 5 at this Q. This is 12. Alright, now we have drawn the diagram. Now what we have to find? A length PQ. So what do we know? We know that angle OPQ is equals to 90 degrees. Correct? Why? Here just mention the theorem 1. Or if you are writing in the exam, just make sure you write a statement in like 5 to 6 words. Understand that how is angle OPQ 90 degrees. Okay? If this is 90 degrees, can I use Pythagoras theorem in the triangle OPQ? Of course I can use. So in triangle OPQ, OQ square is equals to QP square plus OP square. Correct? Yes. Now let us substitute. Okay, I did not add any blank slide. Correct. What is OQ square? 12 square. Tangent PQ at a point P of a circle of meets a line through the center O at a point Q so that OQ is 12 centimeters. Root 119. Yes, so 12 square is equals to 5 square plus PQ square. 144 minus 25 is equals to PQ square. PQ is equals to under root of 9. So 144 minus 25. Correct? So this is 14. This is 3. 119. Root 119. Very good. So we have just applied the theorem here. Nothing else. Next. PQ is the tangent drawn from a point P to a circle with center O, and QOR is the diameter of the circle such that angle POR is 120 degrees. Find angle OPQ. So I hope the diagram is clearly visible. The figure is clearly visible. Let us. We have to find what? We have to find OPQ. This angle we have to find. Right? Again, let us see what concept of circles we can apply. Now, in the given triangle, in triangle PQO, I know that OQP is equals to 90 degrees. Why? Again, theorem 1. So angle OQP is equals to 90 degrees. Why? Radius is perpendicular to the tangent. Correct? So I know that angle OQP is 90 degrees. And angle QOP, this angle QOP. How can I find angle QOP? Bilinear pair of angles. Very good. Correct. So angle QOP, correct? Angle QOP plus 120 degrees is equals to 180 degrees. Why linear pair? So you should know the few basic concepts of geometry to do this, correct? Saraswati Kasturi gave 30 degrees. Lakshmana Prabhu gave 60 degrees. Acha, okay, let's see which is correct. Okay, now angle QOP is equals to 180 minus 120, that is 60 degrees. Alright, now I got angle QOP as 60 degrees. Now what we have to do? Okay, alright, I am doing it here. Now in triangle POQ, we know that sum of the angles in a triangle is 180 degrees. So angle QPO plus angle 60 degrees plus 90 degrees is equals to 180 degrees. So angle QPO is equals to 180 minus 150, that is 30 degrees. Aman Vahora gave 60 degrees. No. Okay, this is 60 degrees. QOP is 60 degrees. Okay. Not the angle we have to find, that is angle OPQ. So what did we get the answer as? 30 degrees. So Saraswati Kasturi, very good. You have given answer correct. So the others, please do check. So what concept did we apply here? We have applied the theorem 1 which we have studied, and also the concept of linear pair. Correct? So if you see any question from the geometry part, you have to remember few concepts, few basic concepts of parallel lines, linear pair, vertically opposite angles, and what else we'll be using, exterior angle or something. Okay, the basic concepts of geometry, if you remember, you'll be easily able to solve the questions. Okay. So everyone, did you all, if you are solving it, and by the way, you have to solve it, okay? If you're solving it, can you all tell me if you got the same answer, 30 degrees, and if you have understood the question? Just type yes or no in the comments. And if you have any doubt, you can ask me through the comments. Alright, next. Now we have seen a tangent. What is the tangent? And also one theorem. Now let us go into next topic. Number of tangents to a circle. Okay. Now you might be wondering, man, there's only one tangent we have just studied. Now again, why are you telling number of tangents? Here we will be checking where the point is in the circle, on the circle, or outside the circle. Okay. Now in the first case, let me take a, this is O, correct? Let me take a point P here. Okay. So if there is a point P inside the circle, can I draw any tangent which passes through point P or from P? No, right? I cannot. So even if I draw this, nothing. So no tangents. Correct? This very good. No tangents. Correct. So what will take the second case? Let us take that. In the second case, the point is on the circle. So let me take this point P. And we have already learned, we have been learning what? That at one point on the circle, there can be only one tangent drawn at one point of contact. Correct? So it will be like this. I'm sorry for the drawing. It should be a straight line. Okay? Whenever you're using, please use a ruler. Okay? Yes. So one tangent. Now, the next case is a very interesting one. Why? Very good, Aman. Very good, Lakshmana Prabhu. Correct. One tangent. Now, let us take a point outside the circle. Let me just take it here. Okay? I hope it is visible. Yes. So from this point P, can I draw any tangents? If yes, how many tangents can I draw? Let us see. From this point, I can draw this, where this meets at point A. Correct? 2 tangents, very good. And I can also draw a tangent like this, correct? PB. So, if a point is outside the circle, very good Saraswati, very good Lakshmana Prabhu, good. So, when a point lies outside the circle, you can draw 2 tangents from that point to the circle. So, here let us mention that we can draw 2 tangents. So, we have understood that wherever the point lies and different conditions of interior or in the inside of the circle, on the circle, outside the circle, correct? Now, let us go next. That is what? There is no tangent to a circle in first case. There is one and only one tangent in second case and exactly 2 tangents in the third case. Now, the length of the segment of the tangent from the external point P and the point of contact with the circle is called length of the tangent from the point P to the circle. Okay, so this statement can be seen many times in the question. You will be given that the length of the tangent from a point P to the circle. So, it is just that make sure that point is outside the circle. Okay, so this is just for the information to solve few problems. Next, so based on this, let us see a theorem and also we'll see proof for it. What is the theorem statement? The lengths of the tangents drawn from an external point to a circle are equal. Okay, that is interesting. Let us see. So this is point P, correct? That is in the exterior of the circle. Let me take this as A and this is B. All right. Now we have to prove, or we have to, the theorem states that, or to prove that PA is equals to PB. All right. So how do we do? Let us see. This is the center O, correct? Let me draw a radius where this radius is perpendicular to the tangent which we have seen in the theorem 1. Next, again, let me draw the radius from the center of the circle to the point of contact B. Okay, and we know that OB is also perpendicular, correct? Now, let me join OP. Okay, so construction we have done. What did we do? So, we have joined OP and OA and OB, correct? Alright, now we know that angle OAP is 90 degrees, angle OBP is 90 degrees. Why? Theorem 1. So just write angle OAP is equals to angle OBP is equals to 90 degrees. Why? Radius perpendicular to tangent. Now I have told you already that you should be having a little knowledge about the other geometry topics, basic topics, right? Because here we will be using the concept of congruency. Okay, you're all aware what is congruency, correct? Now let us take this circle and alright, let me just show it here only. So in triangle PAO and triangle PBO. Okay, right, what do we know? We know that OA is equals to OB. Why? Radius. So come on, OA is equals to OB. Why? Radius. This is a side, correct? Next, angle OAP is equal to angle OBP is 90 degrees. So angle OAP is equals to angle OBP. This is a right angle, so I'm writing R. And yes, SE. How can we use SAS? No. Yes, very good. Common side OP. Very good, Saraswati. Common side OP. OP is equals to OP or PO. This is hypotenuse. Correct? So, if this is the right angle, this will be my hypotenuse. Correct? So with RHS congruency, I can say that triangle PAO is congruent to triangle PBO. So come on, right here. By RHS congruency, triangle PAO is congruent to triangle PBO. And can I say that by CP? Very good, Nitin Mahto. Very good, by RHS criteria. Good. Lakshmana Prabhu, by CP. Yes. Now that we have proved these two triangles are congruent. Now what do we know? By CPCT. What is CPCT? Congruent parts of congruent triangle. Correct? So by CPCT. Okay, just let me write in the next one. By CPCT, we can say that PA is equals to PB. Hence, we have proved that the lengths of the tangents drawn from an external point to a circle are equal. That is, PA is equals to PB. Okay. Now, go through the statement wise because we will be using this theorem in further problems. Okay. Now, so what else did we get from this theorem? Angle OP, yeah, so we know that by CPCT all will be equal, correct? So can I say that angle OPB is equal to angle OPA? Of course, yes, by CPCT. So this OP will be the angle bisector, correct? What is meant by angle bisector? It means that these two angles are equal, right? This OP is the line segment which divides the complete angle APB into two equal angles. So, angle OPB is equal to angle OPA. Alright, so these are the remarks. Next, we can also prove that by Pythagoras theorem. Okay, so RHS, right? Pythagoras. So, let me just tell you how. I'll tell you in a very quick way. So, this is P, correct? So, this is A or this is B and this is O. Right? So, let us take one triangle, okay? In one triangle, POB, by RHS, I can tell that OB square plus OP square is equals to PB square, correct? Next, in triangle POA, I can again tell that OP square plus OA square is equals to PA square. But I know that OA is equals to OB. Why? Radius. So, just substitute, I can tell that OP square. Okay. Yeah, let me just write. Plus OB square is equals to PA square. Now, this is equation 2, this is equation 1. From equation 1 and 2, I can tell that PA square is equals to PB square. So, PA is equals to PB. Okay. So, you can prove this theorem by Pythagoras theorem as well. Okay. Now, did you all understand the theorem and also proofs for it which we have seen in two different ways? I hope it is clear and you have no doubt. And you have understood why it is RHS and not SAS. Correct? Okay. Next. Let us do this. A problem based on the theorem. In the given figure, triangle ABC is circumscribing a circle. Find the length of BC. Come on, this is easy. How? Just apply the theorem. Okay. Alright. So, let me just use another color. Correct. So, we have to find the complete length of BC. What do we know? AN is equals to 3 centimeters. BN is equals to 4 centimeters. And AC is equals to 9 centimeters. Correct? OP square. Yes. Good. Okay, already you're giving very good. One answer I got 12. Okay, let's see if it is 12. I want answers from everyone. Come on, do it. Okay, one answer is 12, one answer is 13. Let me just write your answers here. One is 12, one is 13. I'll keep on solving, you give answers. Let us check, okay? So, if you see this circle, A is the external point. So, AN is equal to AM, correct? So, AN is equals to AM is equals to 3 centimeters. So, if AM is equal to 3 centimeters, I can easily find MC. AM plus MC is equals to 9 centimeters. So, it is 3 plus MC is equals to 9 centimeters. This implies MC is equals to 6 centimeters. So, if MC is equal to 6 centimeters, CL is also 6 centimeters by theorem 2, correct? So, CL will also be equals to 6 centimeters by theorem 2. Next, and if BN is equals to 4 centimeters, BL is also equal to 4 centimeters, correct? So, BL is equals to 4 centimeters. Why again? Theorem. Now, BC is equals to BL plus CL. What is BL? 4 centimeters. Sorry, 10 ma'am. Yes, Saraswati, very good. It is 10. What is BL? 4. What is CL? 6. So, answer is 10 centimeters. Okay, so I got answers 12 and 13 and both are not correct. I'm sorry, you might have made some minute mistake, okay? So, what is the answer? 10 centimeters. Okay. Alright, so let me... Okay, so now you're giving 10, very good. But please make sure you just, whenever you're presenting the exam, okay, make sure you write the steps so that it will be clearer for you to also check the solution at the end of the exam. And if you made any mistake, if you make any mistake, you can correct it, correct? So yes, the answer is 10. Let me move on to the next. Two tangents TP and TQ are drawn to a circle with center O. Okay, there is a circle, center O, alright, and TP and TQ are drawn. So, this is the T, correct, which is outside the circle. Then there is, okay, this Q, there is this point P. TP and TQ are tangents. With a center, okay. Prove that angle PTQ is equal to 2 times of angle OPQ. Okay, so we have to join OP, we have to join PQ. And what do we have to show? PTQ. This angle is equal to 2 times of this angle we have to show. Okay, let's see how. Now, what do we know about the theorem? PT is equals to QT, correct? So, PT is equals to QT. Why? Theorem 2. So, I'm just saying that tangents are equal, correct? So, tangents are equal. So, if PT is equal to TQ, can I say angle TPQ is equals to angle TQP? Can I say that? Of course, yes. Why? If PT is equal to TQ, then base angles are equal, correct? So, angle TPQ is equal to angle TQP. And let us take this angle T as theta. Alright. Now, in triangle PTQ, theta plus angle TPQ plus angle TQP, right? Yeah, is equals to 180 degrees. Why is it 180 degrees? And sum of angles in a triangle is 180 degrees, correct? Next, But these two angles are equal from equation 1. So can I write this as theta plus 2 times of angle TPQ is equal to 180 degrees. Correct? Of course I can write. Now, angle TPQ is equals to 180 minus theta by 2. That is 90 minus theta by 2. Let me name this as equation 1. Okay. Now, next what do we know? We'll check now here. We know that angle OPT is equal to 90 degrees. Correct? So, let us write. We know that angle OPT is equals to 90 degrees. Why is it 90 degrees? Radius is perpendicular to the tangent. Radius perpendicular to tangent. Correct? Now, if OPT is equals to 90 degrees, what is OPT? OPQ plus QPT. Correct? Alright. So, angle OPT is equals to angle OPQ plus angle QPT. Right? Just nothing. OPQ plus QPT. Nothing else I have done. Alright. Now, we'll just substitute. So, what is angle TPQ or QPT? It is 90 minus 1 by 2. Correct? So, alright. So, OPT. Okay. Now, angle OPT is equals to, what is OPQ? Okay. Come on, tell me what is OPQ. We do not know. That only we have to show that angle PTQ is nothing but 2 times of angle OPQ. Correct? So, let us just substitute the values which we know. Okay, so I'm just doing it here because it's very hectic to move. So, what do we know? Angle OPT. OPT is equals to angle OPQ plus angle TPQ. Okay. Alright. So, let us substitute OPQ. We do not know. So, angle OPQ plus what is TPQ? 90 minus theta by Q. Correct? And what is OPT? 90 degrees. Come on. Okay. So, no one is, are you all solving? Because this is a theorem. I can't even ask if you are solving it. Correct? So, please, you can't even type the answer in the comments. So, keep on solving. Okay? Now, angle OPQ is equals to 90 minus 90 plus theta by 2. 90 minus 90, so theta by 2. So, 2 of angle OPQ is equals to theta. And what is theta? It is nothing but PTQ. So, we have proved that angle PTQ is equals to 2 times of angle OPQ. 90 minus angle QPT. QPT or TPQ, you can take anything. It's fine. Yes, yes. So, 90 minus angle QPT. Yes. So, now we know that this is 90, correct? So, I have just mentioned in the next slide that angle OPT is equals to 90 degrees. Why? Because radius is perpendicular to tangent. So, it's just because of the diagram I have to again solve in that only. So, now it is clear, correct? So, angle O. Alright. So, yes, the naming you can do anyhow. It's fine. TPQ, TPQ or QPT, it's same. Let me move on to the next. Two concentric circles are of radii 5 centimeters and 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. Again, this is an NCERT problem. right? This is one of the easiest questions of today. Let us see, let us draw two concentric circles. Okay, for this you can tell me the answer, correct? So keep on doing and tell me the answer. That is the length of the chord of the larger circle which touches the smaller circle. You can type the answer in the comments. So these are two concentric circles, right? What is given? The bigger one's radius is 5, the smaller one it is 3. So this is 5 centimeters, this is 3 centimeters, and this. So let me draw it properly. Yeah. So this is a chord of the larger circle which is touching the smaller circle. Correct? So let me take this as P, this is Q, this is A. Alright, so OQ is 3, OP is 5. So just mention it. OQ is equals to 3 centimeters, OP is equals to 5 centimeters. Now we have to find the length of PA. Very good, Saraswati. The answer is correct. It's absolutely correct. Very good. Now we know that OQ is perpendicular to PA. Why? Radius is perpendicular to tangent, right? Now by Pythagoras theorem, we say that OP square is equals to OQ square plus QP square. So 5 square is equals to 3 square plus PQ square. So PQ square is equals to 25 minus 9, that is 16. So PQ is 4. So if PQ is 4, if we do the same side here, we'll be getting the same thing, correct? So QA is also equals to 4. So what is length of the chord? PA is equals to 4 plus 4, that is 8 centimeters. Very good. So the answer is 8 centimeters. Good. Next. Now let us see how to present word problems, okay? So again, I'm just repeating it because you've already seen the other two sessions. I have told the same thing, how to present a word problem. So read the problem out loud, form a clearer picture in your head what is being asked in the question. Next, list what is given. So write given and list what is given in the question, okay? Next, write what do you have to find from the question. That is to find what, right? Next, solve the problem stepwise and also check your answer at last, okay? So after completion of your exam, make sure you check your answer. Next. So these are the steps we'll be following in the first problem, okay? From the next, I will, at least one problem, I'll tell you how to present, okay? A triangle ABC is drawn to circumscribe a circle of radius 4 centimeters such that segments BD and DC, into which BC is divided by the point of contact D, are of length 8 centimeters and 6 centimeters. Now just see the figure. Find the side AB and AC. So what is given? CD is equal to 6 centimeters, BD is equal to 8 centimeters, and the radius is 4. That is given. OD is equals to 4 centimeters and DC is equals to 6 centimeters, or CD is equals to 6 centimeters and BD is equals to 8 centimeters. And what do we have to find? To find AB and AC. So we have to find the lengths of AB and AC. Okay. So this also you solve and let me know what is the measure of the AB and AC in the comments. Okay. Now let me just for my convenience name these points. Let me take this as E, this as F. Okay. Now I know that if CD is equals to 6 centimeters, CE is also 6 centimeters. Why? Equal tangents from the exterior point to the circle, correct? So CD is equals to, CE is equals to 6 centimeters. I'm just writing here theorem, okay? But when you write, you just write the statement, okay? Next, If DB is equals to 8 centimeters, BF is 8 centimeters. So BD is equals to BF is equals to 8 centimeters. Now we do not know any information about AE and AF, but we know that they are equal, correct? So let AE is equals to AF is equal to be X. Alright. Now, how do we generally find the area of a triangle where the altitude is not mentioned? We use Heron's formula, correct? So let us use Heron's formula and find the area of triangle ABC, okay? For that, AB is equals to, what is AB length? X plus 8, correct? So 8 plus X. Next, BC is equals to, what is the length of BC? 6 plus 8, 14. So let us write 14 centimeters. These are all in centimeters, okay? Next, what is the length of CA? Let us see. CE is equals to 6, then this is X. Correct? So X plus 6 or 6 plus X centimeters. So to use Heron's formula, we need to know the semi-perimeter, correct? So S is equals to A plus B plus C by 2. So 8 plus X plus 14 plus 6 plus X by 2. So this is the little bit lengthy problem. So please do try, but it's one of the important problems, okay? So 14 plus 8 plus 6, so 28. 28 plus 2x by 2. That is 14 plus x. So semi-perimeter is equals to 14 plus x. Now we'll find the area. Area is equals to under root of S of S minus A into S minus B into S minus C. Correct? Now, let us just substitute. What is x? 14 plus x. 14 plus x into 14 plus x minus 8 plus x. 14 plus x minus 8 minus x. Next, 14 plus x minus 14. 14 plus x minus 14 into 14 plus x minus 6 minus x. Alright, let us simplify this. 14 plus x into 40 plus x minus x plus x. Okay, not here. Alright. Yeah, here plus x minus x. Correct? So what we'll get? 14 minus 8 is how much? 6. And minus 14 plus 14. So here we'll get x. Here we'll get 8. Correct? So can we take something as root? Yes, I can take 4. So 4 root of 3x into x plus 14. This is my area. But now you might be wondering, ma'am, what we'll do with this? We have no equation to solve or no nothing to equate it to find the value of x, correct? But wait. So here we got this area, right? Now let me just go here and explain you something. So OD is equals to 4 centimeters and this is perpendicular, correct? So if I just draw this, I got 3 triangles, correct? So if I join OC, OB and OA, the complete triangle is getting divided into 3 triangles, right? Now again, let me just join OF and OE. Again, this is 4, this is 4. Why? Radius is 4 centimeters, correct? Now, in the one given triangle OCB, can I use that to find the area half into base into height? Of course I can use, correct? So now for every triangle, I can find the area using the formula half into base into height. And then if I add everything, I can equate it to this. So we'll be getting 2 equations. When we equate, we'll be getting the answer. Okay, let's do. Yes. So now, okay, you're not able to see. Right. So now in triangle, first let me take OBC, okay? In triangle OBC, what is the height? 4 centimeters. What is the base? 8 plus 6, 14 centimeters. So half into 4 into 14. So in triangle OBC, area of triangle OBC is equals to half into base into height, that is half into 14 into 4. So 2 times 2, that is 28. Alright. So I'm just writing the numerical. You can just put square centimeter. Now one triangle we have seen, but we have to see how many triangles? All the 3 triangles. Let us see. Now again, in triangle OAC. So what is C? 6. This is x. So half into x plus 6 into 4. Correct? In triangle, area of triangle OAC is equals to half into 4 into x plus 6. So it is 2 into x plus 6. Correct? And we are left with only one more triangle, that is area of triangle. What will be the triangle? OAB. Half into 4 into x plus 8. Right? So let us write OAB. Half into 4 into x plus 8. That is 2 of x plus 8. Now what will be the area of complete triangle? Area of triangle ABC is equals to sum of areas of all the 3 triangles. Correct? So do the sum. 2x plus 2x, 4x plus 2 6 are 14, 2 8 are 16 plus 28. So we'll be getting 4x plus 14 plus 16 is 30 plus 28, 58. Correct? Yes, so we'll be getting 4x plus 58. Now let me name this as equation 2 and this as equation 1. So we have to equate it, correct? Let us do it. So equation 1 equals to equation 2 because both are the areas of the same triangle ABC. So let us equate it. Alright, so I'm doing it here. 4 times of 58 is equals to 4 of root 3x plus x plus 14. Correct? Okay. So now we have equated. So what do we have to do? To remove the square, let us do squaring on both sides. So 4x plus 58 whole square is equals to 16 times of 3x of x plus 14. Correct? 3x of x plus 14. Okay. Alright, so there is no space to do this. So I have to erase this. Let me erase and then do it, okay? Okay, so these two I'll okay, I'm just sorry, wait for a second, okay? Yeah. So let us do 4x plus 58 whole square is equals to 16 of 3x plus x plus 3x of x plus 14. So 16x square plus 58 whole square. Okay, so let us do 58 into 58. 8 8s are 6, 8 5s are 40, 46, 5s are 40, 5 5s are 25, 29. So 4, 6, 9 plus 4, 13, 3, 3, 6, 4. So you have to also solve. It's 4x plus 56. Okay. Are you sure it is 4x plus 56? Okay, let us see. 28 plus 12 plus 16, right? 3, 4. Yeah, I'm so sorry. It is 56. SRH dude, thank you. It is 56. Yes. So, we have made some calculation mistake. 56. Okay, now again. So, this is a lengthy problem and this is a last problem. Okay, so please do it and then tell me the answer as well. But I guess this is an NCERT problem also, correct? So, you might have solved like so many times the same problem. Okay, now 4x plus 56 whole square is equals to 16 of 3x square plus 14 into 3, 3 4s are 12, 52. So, 3, right? 42. All right. Now let us take 4 common here. 4 square, 4, okay. So, all right. If I take 4 common, what will I get? X plus 4 1s are 4, 4 4s are 16. Correct? If I take 4 common, in this I will be getting x plus 14. So, this whole square is equals to 16 of 3x square plus 42. 16 of x square plus 2 into 14, 28x. What is 14 square? 196 is equals to 16 of 3x square plus 42. 16, 16. Right? Alright, let us solve 3x square minus x square. 2x square minus 28x minus 42 minus 196, 154, correct? So, you will be getting a quadratic equation, correct? Now, do solve this quadratic equation and tell me in the comments what is x, okay? I am stopping this here because you know how to solve the quadratic equation. I have just told you how to solve the problem. So, let me tell you what did we do. So, we have taken the area of complete triangle using the Heron's formula. We have found the area. Then we have joined this OA, OB, OC. We will be getting 3 triangles. We have seen that sum of all these triangles is nothing but area of one big triangle. So, we have equated these both. Okay. I know this is a lengthy problem. You can try it. Okay. Next. Okay, prove that opposite sides of quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, so what do we have to do? This is O, this is A, this is B, this is C, this is D. And A, B, C, D are all the external points of the circle, and we say that OA is equals to OP, so QA is equals to AP, PD is equals to DS and so on. Why? When you draw tangents from the external point to the circle, they are equal in length. We have seen the theorem, also proved it. Correct? So now, we have also seen one observation that if I join OD, I know that this angle is equals to this angle. Why? Angle bisector, we have seen it in the remarks and in the observations, right? So, let me take this 1 and 1. Okay, I am just explaining it. I am not writing any steps. Okay. Next, let me join OC. Again, this will be equal to 2. This is also 2. And this is 3. This is 3. If I join OA, this is 4, this is 4. So these two angles are equal. Why? Angle bisector. Correct? Now, what do we know about the sum of the angles in the quadrilateral? Sum of angles in quadrilateral is equals to 360 degrees. Correct? So, angle 1 plus angle 1, angle 2 plus angle 2 plus angle 3 plus angle 3 plus angle 4 plus angle 4 is equals to 360 degrees. So, I can write 2 of angle 1 plus 2 of angle 2 plus 2 of angle 3 plus 2 of angle 4 is equals to 360 degrees. So, if I take 2 common here, what do we get? Angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 180 degrees. Right? This is my equation 1. Okay. Now, what we'll do? We'll take again one triangle. Okay. ODC. So, in triangle ODC, angle 1 plus angle 2 plus angle DOC is equals to 180 degrees. Correct? DOC is equals to 180 degrees. So, angle DOC is how much? 180 minus angle 1 plus angle 2. Right? The same way, let us take triangle OAB. Okay? So, in triangle OAB, what do we know? Angle 3 plus angle 4 plus angle OAB or BOA is equals to 180 degrees. Correct? So, angle BOA is equals to 180 degrees minus angle 3 plus angle 4. Alright, your life. Hello, hi. Okay, now this is my equation 2, this is my equation 3. So, I am adding equation 2 and equation 3, okay. So, add equation 2 plus equation 3. What do we get? Angle DOC plus angle BOA. Angle DOC plus angle BOA is equals to 180 plus 180 is how much? 360 degrees. Correct? So, 360 degrees minus angle 1 plus 2 plus 3 plus 4. So, angle 1 plus angle 2 plus angle 3 plus angle 4. But in the previous slide, we have seen angle 1 plus 2 plus 3 plus 4 is equals to 180 degrees. Correct? So, I can write this as 180 degrees. So, 360 minus 180 is 180 degrees. So, hence we have proved that the opposite sides of quadrilateral circumscribing a circle subtend supplementary angles, that is this plus this is equals to 180 degrees. Okay. So, yes, this is it for today's session. I hope, okay, it's time. Okay, this is a subjective question pattern CBSE is giving, alright. So, please make sure you solve. This is not objective as you've written in term 1. So, make sure you practice, you get answers, alright. So, okay, this is it for today's session. Thank you.